Voyager 1 will die alone, not in a blaze of glory, not in a collision with some distant rock, not in any way that feels dramatic or cinematic. It will die the way a heartbeat stops, slowly, weakly, one pulse at a time, until there's nothing left. Picture this spacecraft, roughly the size of a small car, hurtling through absolute darkness at 61,000 kilometers per hour. No sun warming its golden panels, no planet in sight, no star for trillions of kilometers in any direction. Just blackness, stretching infinitely in every direction, cold and empty and eternal. It has been traveling for 47 years, and at this exact moment, while you're listening to this, it is the farthest human-made object in existence, more than 25 billion kilometers from Earth, so impossibly far that a radio signal, traveling at the speed of light, the fastest speed anything can travel in this universe, takes over 23 hours just to reach it, and another 23 hours to come back, 2 full days for a simple hello. That is how alone Voyager 1 is. In this video, we're going to follow Voyager's entire journey, from the moment it left Earth to the day it finally falls silent, and then far beyond that, into a future so distant that everything humanity has ever built will be dust long before Voyager stops moving. The real question isn't how far Voyager can travel before it dies. The real question is what happens when there's no one left to listen to its final whisper. Let's begin with what's keeping Voyager alive right now, because it's definitely not solar panels. At 25 billion kilometers from the sun, sunlight is practically non-existent. The sun from Voyager's position looks like just another faint star, something you could block with your thumb. So instead of solar panels, Voyager carries 3 radioisotope thermoelectric generators, small nuclear devices that convert heat from decaying plutonium into electricity. When Voyager launched back in 1977, those generators produced about 470 watts. That's barely enough to power a few household light bulbs. And that was all the energy Voyager ever had to run everything. Its computers, its heaters, its communication systems, every scientific instrument on board. 470 watts, the difference between life and death in the void. Here's where it gets devastating. Plutonium decays over time. It has a half-life of 87.7 years, which means Voyager's power supply is slowly, steadily, irreversibly dying. Every single year, it loses approximately 4 watts. That doesn't sound like much until you realize that over 47 years, Voyager has lost nearly 200 watts, almost half its original power, vanished forever. NASA engineers have been forced to make brutal choices about what stays on and what gets permanently shut down. Think of it like a house where the electrical grid is slowly failing. At first, you switch off the lights in rooms you don't use, then the heating goes, then the refrigerator, then one by one, every appliance that made the house feel alive. Eventually, you're sitting in a single dark room with one flickering candle, knowing that soon, even that small flame will go out. That is exactly what's happening to Voyager right now. One room, one candle, waiting for darkness. When Voyager launched, it carried 11 scientific instruments, cameras to photograph alien worlds, spectrometers to analyze atmospheres, particle detectors to study cosmic radiation, magnetometers to measure magnetic fields. 11 different tools designed to explore the unknown. One by one, over the decades, they've been switched off. The cameras were the first major casualty. They were shut down in 1990 after capturing one final image, the pale blue dot, that haunting photograph of Earth as a tiny speck suspended in a sunbeam 6 billion kilometers away. Carl Sagan described it perfectly when he said, "That's here. That's home, that's us, everyone who ever lived, every king and peasant, every young couple in love, every mother and father, every saint and sinner in the history of our species, lived on that tiny mote of dust." That was the last thing Voyager's cameras ever saw. After that image, the camera software was deleted from Voyager's computers. The ground equipment that could interpret those images was decommissioned. Even if NASA desperately wanted to turn those cameras back on today, they couldn't. That capability no longer exists, gone forever. By 2025, the cosmic ray detector was shut down. By 2026, another instrument follows. Now only 2 scientific instruments remain active, 2 out of 11, on a spacecraft 25 billion kilometers away. That's all that's left of humanity's greatest voyage of exploration. But here's what most people don't realize. It's not just the instruments that are dying. The heaters are failing too, and this is where the situation becomes truly critical. Voyager has small heaters designed to keep its fuel lines from freezing in the unimaginable cold of deep space. If those heaters fail, the hydrazine propellant freezes solid. If the propellant freezes, Voyager can no longer fire its thrusters. If it can't fire thrusters, it can't point its antenna toward Earth. And if the antenna drifts off target by even the smallest fraction, the signal is lost. Not temporarily, permanently. There is no rescue mission. There is no reboot. At 25 billion kilometers, you either maintain that razor-thin radio connection or you lose the spacecraft forever. NASA engineers estimate they can keep at least one instrument running into the early 2030s. The generators might produce enough power to transmit basic data until around 2036, maybe 2038 if they're incredibly lucky. But these are optimistic estimates. After nearly 5 decades in the most hostile environment imaginable, every single day is borrowed time. A single frozen fuel line, a single glitched computer, a single degraded component. Any of these could end the mission overnight, without warning, without a chance to say goodbye. So after all that, what has Voyager actually accomplished? The answer is staggering. Voyager 1 flew past Jupiter in 1979 and discovered active volcanoes on its moon Io, something nobody had predicted. It reached Saturn in 1980 and revealed thousands of intricate ring structures where scientists thought there were only a few simple bands. After Saturn, Voyager's trajectory flung it upward, out of the plane of the solar system entirely, onto a one-way path toward the stars. For 3 decades, it just kept going, past Uranus, past Neptune, past Pluto, past the Kuiper Belt, into regions of space no human instrument had ever measured. Then in August 2012, something truly extraordinary happened. Voyager 1 crossed the heliopause, the boundary where the sun's influence ends and interstellar space begins. It became the first human-made object to leave the solar bubble entirely, the first piece of humanity to touch the void between stars. And what it found surprised everyone. The interstellar medium wasn't what scientists had predicted. The magnetic field was different. The plasma density was unexpected. Voyager didn't just confirm theories, it completely rewrote them. Now here's where the scale becomes almost impossible to grasp. Voyager is currently about 165 times farther from the Sun than Earth is. That sounds impressive. It's actually nothing. The Oort cloud, the true edge of our solar system, begins around 2,000 astronomical units away. The outer edge stretches to 100,000 astronomical units. At its current speed, Voyager won't reach the inner boundary of the Oort cloud for another 300 years, and clearing the outer edge, that will take approximately 30,000 years. Let that number sink in. 30,000 years ago, humans were painting animals on cave walls. Agriculture didn't exist. Cities hadn't been built. Writing hadn't been invented. That's the timescale we're talking about. And even after 30,000 years, Voyager will still be nowhere near another star. But eventually, it will approach one. In about 40,000 years, Voyager will make its closest approach to a star called Gliese 445, a small red dwarf passing within 1.7 light-years. That's still over 16 trillion kilometers. Voyager won't enter that star system. It won't orbit anything. It will simply drift past, a cold, silent piece of metal in the vast emptiness between stars, and then it keeps going forever. Researchers have calculated how long before Voyager might actually collide with anything. The answer is almost incomprehensible, approximately 100 quintillion years, a 1 followed by 20 zeros. Voyager will outlast the Sun. It will outlast every star currently shining in the Milky Way. It will outlast the galaxy itself. But here's what makes all of this beautiful, rather than tragic. Attached to Voyager's side is a golden record containing 115 images of Earth, greetings in 55 languages, 90 minutes of music from cultures around the world, and sounds of our planet, wind and rain and ocean waves, birds singing, a mother's heartbeat, a baby's first cry. A message in a bottle, cast into the cosmic ocean, carrying proof that we existed. Will anyone ever find it? Probably not. Interstellar space is incomprehensibly empty. The golden record may drift for longer than the age of the universe without being discovered, but that was never really the point. The point is that we made it. A species on one small planet looked up at the stars and decided to send a greeting into the darkness. Not a weapon, not a warning, just a hello, knowing that no one might ever hear it. We sent it anyway because that's who we are. Voyager 1 will die alone, 25 billion kilometers from home, but what it carries will travel forever. That's not tragedy, that's legacy.